Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial, we're going to be determining if two lines intersect or not. Now, before we get started, make sure to subscribe to the channel for notifications on more math tutorials. All right, now let's take a look at this example. In our first example, we're asked to determine if line 1 and line 2 intersect. So how do we do this? Well, if we can find values for s and t that make the x's, y's, and z's in L1 and L2 equal one another, then that means that L1 and L2 do in fact intersect. So let's start off by setting the x's, y's, and z's in L1 and L2 equal to one another. Next, I'm going to get all of the s's and t's on one side of the equal sign and all of the standalone constants on the other side. Now at this point, we have a system of equations, and we're going to solve this system of equations to get values for s and t, and then we're going to plug those values into, say, 5 minus 12t equals 3 plus 8s to see if we get the same number on both sides of the equal sign. Now, if this goes over smoothly, that means that there are values for s and t that make L1 and L2 equal one another, and therefore that'll mean L1 and L2 are intersecting. So let's start solving our system of equations, and we'll start with the first equation. We'll solve for t first, so let's add 8s to both sides. And then we'll divide negative 12 on both sides to get t equals negative 2 plus 8s over negative 12. Now we can actually factor out negative 2 from the numerator and the denominator, and that'll leave us with 1 minus 4s over 6. So we found t as 1 minus 4s over 6, and we'll plug that into the second equation in our system to get a value for s. So I'll subtract 6s from both sides. And then I'll multiply both sides times 6 to get rid of that 6 in the denominator. Then this will give us 9 minus 36s equals negative 18 minus 36s. So now let's get all of the s's on one side of the equal sign. And notice on the left-hand side of the equal sign, we have negative 36s plus 36s, and that's just going to give us 0. So that means this system of equations has no solution, and therefore these two lines, L1 and L2, do not intersect. So now that we know that L1 and L2 do not intersect, we'll move on to testing if they're parallel. We'll start with writing their direction vectors. So L1 has a direction vector of negative 12, 9, negative 3, and L2 has the direction vector 8, negative 6, 2. And L1 and L2 are parallel if these two direction vectors are scalar multiples of one another. So in order to determine if there's a scalar that relates these two vectors, I'm going to multiply L2 times lambda. And then I'm going to set the x's, y's, and z's in the two direction vectors equal to one another. So at this point, we're going to solve for lambda to see if we get the same value for lambda for x, y, and z. For x, when we divide 8 on both sides, we get negative 12 over 8. And then this can simplify down to negative 3 over 2. For y, when we divide both sides by negative 6, we end up with 9 over negative 6. And then this simplifies down to negative 3 over 2. And then for z, when we divide both sides by 2, we end up with negative 3 over 2. So we see that we got the same lambda value, negative 3 over 2, for x, y, and z. So that means that these two vectors are scalar multiples of one another. Hence, our lines L1 and L2 are parallel. Now let's take a look at one more example. So we've got two new lines and we're being asked, do they intersect? And to test for intersection, we'll set the x's, y's, and z's in L1 and L2 equal to one another. Then we'll get the s's and t's on the same side of the equal sign. And at this point, this will become our system of equations. And now we'll solve this system of equations starting with the first equation. We'll solve for t, so let's add 4s to both sides. And then we'll divide 2 on both sides to get t equals negative 2 plus 4s over 2. And then we'll factor out 2 from the numerator and the denominator. And that'll give us negative 1 plus 2s in the numerator and 1 in the denominator, which we can really just get rid of altogether. So we've got t equals negative 1 plus 2s, and we'll plug this into the second equation in our system, and we'll simplify to get 1 minus 2s plus 2s equals -1. So this -2s and this +2s cancel out, and we see that this system has no solution. And that means L1 and L2 do not intersect. So let's move on to testing if they're parallel. We'll start with writing out their direction vectors. L1 has a direction vector of 2, -1, 3, and L2 has a direction vector of 4, -2, 5. And we need to figure out if these two vectors are scalar multiples of one another. So we'll multiply L2 times lambda, and then we'll set the x's, y's, and z's in these two vectors equal to one another. So now we can start solving for lambda. For x, when we divide both sides by 4, we get 2/4, and then this simplifies down to 1/2. For y, when we divide both sides by -2, we get -1/2, which of course just equals 1/2. And then for z, when we divide both sides by 5, we end up with 3/5. So x and y have the same lambda value, but z does not. So L1 and L2 are not parallel, and we found earlier that they're not intersecting either. So that means our two lines, L1 and L2, are skew. And there you have it. In the first example, we showed that the two lines are parallel, and in the second example, we showed that the two lines are skew. If this video was helpful for you, give it a thumbs up, like the video, and also subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching The Numbers Game.